Hello and welcome back. So far in this class, we've been concentrating on the data itself. We've talked about how to collect it and how to summarize it with things like the quartiles and the median and so on, how to compute things like the mean and the standard deviation and the interquartile range and so on. But it's been pretty focused on the data itself. Now we're going to try to take a step backwards into the more theoretical side of statistics and look at the theoretical world as opposed to the data or the real world. In order to motivate things, let's consider again one of the examples that came up previously, namely when we considered life expectancies for different countries around the world, and we compared them by what region of the world they were in. In particular, remember when we compared East Asia and the Pacific compared to South Asia? Well, for these two regions, we could compare things like the quartiles and the median and the minimum and the maximum, and we could summarize this using the side-by-side box plots, which we did, and we saw from there that it appears that East Asia and the Pacific is a little bit higher overall compared to South Asia, but it was pretty close, and we didn't know if that was a significant difference or not. Well, how can we try to make sense of that? One thing we can do is try to put it in a broader theoretical context by pretending that the East Asian and Pacific countries are actually samples from some theoretical or imagined population of an infinite number of the kind of countries that are in East Asia and the Pacific. And similarly for South Asia, we can imagine that the data we have actually comes from a bigger sample. Now, in this case, there is no bigger population because really there's just those countries in East Asia and the Pacific, and there's just those countries in South Asia, but nonetheless, we can imagine things and try to make a theoretical model that way. We'll come back to that later, but that's going to come up a lot for us. For example, we can also consider our case of the skeletons. Well, for the skeletons, we had various data about the age differences and the body mass index and other things like that, and they were all good data, and that's the real world or the data side of things. But we can also imagine that these 400 skeletons are representatives of some big population of all the skeletons that are out there, or all the skeletons that we might consider, and we can try to draw inferences and conclusions about the entire skeleton population, the theoretical world, by using the data that we have in the real world. Similarly for the HPV vaccine, we said, well, we have, for example, there was a study that looked at thousands of young women and measured what happened to them when they got the vaccine, but still these young women are a representative sample from all the young women all around the world. So in all these cases, we consider the real world with the actual experimental data, and we also have the theoretical world, which is the theoretical modeling that we're trying to do. In order to make all of these ideas more concrete, let's do our own experiment right now. I have here an ordinary Canadian $2 coin. It's got heads on one side and an animal for tails on the other side. I'm going to flip it 10 times and let's see what result we get. Ready? Here we go. First flip, tails. Second flip, heads. 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 Tails. Heads. Tails. Tails. Heads. So there we go. We flipped the coin 10 times and we got a total of 6 heads out of 10. So what does this mean? Well, from the theoretical perspective, we can say in the theoretical world, the coin is symmetric. It's equally likely to come up heads or tails every time. So theoretically, we should expect to get 5 heads out of 10. And yet, from the experimental world, from the data that we got, we can see that the real world value was 6 heads out of 10. So what does this mean? This means that we don't always get exactly 5 heads out of 10, and we're going to learn to study the relationship between how many heads we might expect, like 5 out of 10, and how many heads we actually get, which in this case was 6 out of 10. Let's do a second experiment now too. I have here a cap from a beer bottle. Now it's red on one side, and it's kind of silver colored on the other side. I'm going to now try flipping this 10 times. In this case, the theoretical value, well, I don't know. I've never flipped a beer bottle cap before. I don't know if the true probability of coming up red versus silver is 50-50 or some other probabilities. All we can do is do the experiment. So here we go. Ready? First flip, red. Second flip, red. Silver. 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 Red. Red. Silver. So in this case, the data from the real world said that there were just 4 reds out of 10 flips, or 40%. Now, from the theoretical world, we don't know how many times it's supposed to come up red because we don't have experience with flipping beer bottle caps. So, what can we conclude in a case like this? We're going to find out as we move forward that in order to understand the relationship between the results in the real world and the underlying values in the theoretical world, we're going to have to learn a little bit about the subject of probability theory, and that's what the rest of this week's lectures are going to be about.